Hello, in this video, I'm going to show you how you can make exponential smoothing work in R to make a forecast. So in the previous video, we looked at making moving average forecasts in R and by using, of course, the forecast package. We installed it earlier and then we imported it. Make sure that if you have not imported this yet, make sure that you execute this line 4. Um, in exponential smoothing, which is as simple as moving average method. It is very straightforward to make a forecast with it. And the function that we are going to be calling here is SES. It stands for simple exponential smoothing. If you like to bring up the help menu, you can call help in parentheses SES. It's going to bring out the help menu here. You can click on it and then you can look further. Let's start with our making our first forecast. So remember, in the exponential smoothing method, we do have a smoothing constant alpha, and it is just a constant number between 0 and 1. It can be specified by us, and it can be estimated by using some other methods. But for this lecture only, we are going to take it as a constant. So we're going to take it as a 0.65, and we're going to change it along the way. Okay. So SES function, it is going to be taking the first parameter as the data itself. We do have the burglaries, monthly burglaries data, and then we actually use it to make a forecast object, SES1. And I just typed this name. It can be any name, as I said, as long as you use the same name over and over, it can be any name. All right. And then the alpha parameter in this function is going to be giving you the opportunity to specify your alpha value. As I said, I'm going to be taking it as 0.65 here. And let's execute this line. I'm hitting command and return. You are running a PC, then you will have to enter, so you will have to hit control and enter. It worked. Let's see what it is going to bring me in a model. So SES1 is going to be created as a data frame, right? Remember, the moving average was created as a time series. If it is a data frame, you can look into certain parameters into it, right? A model is one of them. It's going to, by using this dollar sign, you can specify whichever column that you are referring to here, right? It has residual states, it has many other parameters here, but the model parameter is going to be very useful. So if you call it, you see that it specifies it as simple exponential smoothing model with alpha 0.65. And it gives you that, this is the initial state that it used, and these are certain error metrics that it came up with. It's not really that super helpful to look at it here because we haven't made any forecasts yet. We're going to be making forecasts again similarly to the way that we did it for moving averages by using the forecast function. And in the forecast function, the first object that we put in is exactly the simple exponential smoothing object that we used. We just created SES1. And similarly for the next 10 months, and it's going to create a forecast, already forecast, made forecast for the next 10 months. All right, let's execute this line. It's created it here as a data frame. You can look further into it. You can see these are all the error metrics that it has. And let's see if we call it itself. It gives you the point estimate, 80% confidence interval and 95% confidence interval. Let's check out the accuracy metrics. As you can see, the MAPE is very high here, right? It gives me 25.7. With moving average methods, with K equals to 4, I think I was able to get it down to 8.9. If you look at the plot, and this is what you get as a forecast plot. So the actual burglaries data, and then the forecast here on the bottom right. Let's change this alpha to 0.3 to see how it looks like. And then it will be another object, SES2. This is simple exponential smoothing object. And by actually calling for the fitted values, you could literally get these are the forecasts that you could get for the current time periods, not for the future, right? So the fitted is also another column that you can find under SES2 object. All right, so let's make a forecast by using this alpha equals 0.3 with exponential smoothing function for the next time, for the next 10 months for the burglaries values. We're going to compare it with the one that we, oh, it hasn't been found yet because we haven't run this. Um, well, we did run it, but I think I put SES2 here by mistake. It should have been the previously created exponential smoothing object, right? So by using SES function. So let's rerun it again. It should work. Yep, it worked, and let's call the forecasts. So these are the forecasts that it came up with. Let's take a look at the accuracy values. NMAPE value didn't really go that much down, but end up in 25.76. Let's take a look at the plots itself. This will be the further forecast that we could make. All right, so if you like to try a different alpha value, all you have to do is to copy this entire thing and change these names, right? And change the alpha parameter and make your own forecast with a different alpha value. This is how simple it is to make simple exponential smoothing forecasts in R. Next video, I'm going to show you how you can make a forecast with Holtz and Winter's method, which is actually a cool method that you could use when you see a trend and seasonality. I'll explain it later in the next video.